Imagine if you walk up to a robot and tell it to grab an object for you and move it across the table. In order for the robot to do this, it needs to understand the language you're speaking in, what the object looks like, and how to actually move it. Although there have been many advances in robotics, this simple task is still difficult for robots to achieve. As a rising senior in computer science, getting robots to perform these types of tasks is something that I've always wanted to do. I am Sajan Patel, and this year, during the Summer Undergraduate Research and Engineering program at the University of Michigan, I got to work under Dr. Jason Corso, whose computer vision lab is tackling the problem of using cameras to guide robotic arms as they manipulate small tabletop objects. In 2014, his lab published a paper describing a model that allowed them to join the natural language processing necessary for robots to understand the commands spoken to them and the visual representation of the objects they were commanded to move. This summer, I worked on the problem of using vision feedback from cameras to guide a robotic arm to actually detect and move these objects. The robotic arm we used has 6 degrees of freedom and can move in 3 dimensions around the tabletop. Using an Asus Exteon camera, which combines the RGB and depth cameras into one unit, we used an algorithm that detects the 3D position of the objects on the tabletop. From there, we used inverse kinematics to determine the correct joint angles the arm needs in order to pick up the objects and move them. In addition to deriving the algorithms and equations for detecting the blocks and moving the arm, I worked on implementing a software base in C++ for the lab to use when working with these robots. I used object-oriented programming when developing the software to make it reliable, easy to maintain, and extensible. Ultimately, our goal is to demonstrate the ability of the robotic arm to manipulate and stack blocks on a tabletop while using vision feedback. This summer experience has been an amazing one for me, and I've learned many new things through this research in robotics. I'm very grateful to Dr. Corso for guiding me through this project, and I hope to continue working with his lab in the future.